today's lecture is on bleaching operation. Okay, to start with, what is bleaching? Okay, bleaching is the treatment of wood pulps with chemical agents to increase their brightness. To increase the brightness, you need to remove color from the pulp. Okay, so what are the color imparting elements in the pulp? The color is due to the lignin extractive present in the pulp. Okay, so these color imparting elements are called chromophores. Chromophores is basically the color imparting material for any material, not in pulp. The chromophores are called the color imparting material for any material. Okay, prior to bleaching, actually the color of the pulp is from cream to dark brown. Okay, bleaching actually removes the color or alters the color to get a pulp with higher whiteness or brightness. Now let's talk about what is the difference of approach between bleaching of chemical pulp and bleaching of mechanical pulp. Bleaching of chemical pulp actually achieved by removal of lignin and definitely bleaching the residual lignin. Okay. Lignin removal in chemical pulp actually leads to greater fiber to fiber bonding strength of the paper. Okay. But here in chemical pulp bleaching, strong chemicals are used to bleach. Okay. That also decreases the length of the cellulosic molecule and thus it results in weaker fibers. Whereas for mechanical pulps, the approach is that it chemically alters the portion of the lignin molecule that absorbs the light. Okay, so actually it rather than removing the lignin, it actually alters the lignin actually to increase the brightness. Okay, basically bleaching mechanical pulps is referred to as lignin preserving, and it is also called brightening actually, because you are not removing the color imparting material, that is the lignin, rather than you are altering it to get higher brightness. So it is basically brightening, and this is also called brightening to distinguish from it from the bleaching of chemical pulps. Now in previous slide we have learned that the mechanical pulp bleaching process is also called brightening because it doesn't remove the lignin, rather than it alters the lignin to get the brightness. Okay, now what is the brightness? Brightness is a term used to describe the whiteness of pulp or paper. Okay, this is on a scale of 0 to 100%. 0 is absolute black and 100 is absolute white. Okay, that is relative to a MgO standard, which has an absolute brightness of about 96%. Okay, by the reflectance of blue light at 457 nm from the paper. Okay, and now let's have a look at the approximate brightness level of some pulps. Okay, by now you must be understanding this term. Unbleached craft pulp is having 20% brightness, unbleached sulfite pulp is having 35%, newsprint is having 60% brightness, ground wood pulp is having 65% brightness, and so on. You can check. Okay. Okay, now the color reversion. Color reversion is basically the changing of color even after bleaching, or the life length of the whiteness that you get after bleaching. Okay, basically color reversion is the yellowing of paper or pulp on exposure of an external stimuli like air, light, heat, okay, the fungi, okay, basically these modifies the residual lignin that present in the pulp. Okay, basically lignin is chromophore. Okay, so when the external stimuli modifies this lignin, okay, then the color reversion may take place. As in the mechanical pulping, the lignin alters actually. In bleaching, lignin is getting altered rather than separated. Okay, so the color reversion chances or possibilities are more in case of mechanical pulps. Okay, but for chemical pulps, the color reversion chances are less as you remove the lignin rather than just altering it. Okay, but there is a possibility of color reversion of chemical pulps also at a high temperatures. Now talking about the consistency of pulp when the reactions are taking place. Different reaction requires different consistency, but in different bleaching stages basically carried out at consistency between 3 to 20%. Okay. Higher consistency, that is 10 to 20%, are used with chemicals such as oxygen bleaching, peroxide bleaching, that we will be learning in the next slides, and hypochlorite. Actually, these chemicals react with lignin very slowly. Okay. By using higher consistencies, higher concentration of bleaching agents are realized for a given chemical loading. Actually, this increases the reaction rate. Okay. Okay, talking about bleaching agents, there are two kinds of bleaching agents available. First is reductive and another is oxidative. Okay, you are familiar with this term, reductive and oxidative bleaching agents, right? Okay, examples of reductive bleaching agent like sodium hypochlorite, calcium hypochlorite. Okay, then oxidative bleaching agents are like your chlorine dioxide, elemental chlorine, hydrogen peroxide. Again, you can classify the bleaching agents in another two categories like chlorine containing bleaching agent and chlorine free. Like chlorine containing are like Cl2, ClO2, NaOCl. Okay, and chlorine free are like oxygen, H2O2. Okay. In the below table, you can check the type of reactions and the pH level. Like Cl2 and O3 gives you acidic reaction, like pH like acidic. For ClO2 and O2, acidic plus alkaline can be possible. For NaOCl, H2O2 alkaline. Okay, and the reaction site in the lignin structure is also defined at the table. You can check. Now you can check the oxidizing equivalence of the chemicals. Okay, here you can check the abbreviation of bleaching steps also, that you will be learning in the next slide. Like for chlorination it's C, for chlorine dioxide it's D, for hypochlorite it's H. You can check the table basically. Okay. Now at the bleaching agent slide, you have noticed that it is written there in the table, below table, the reaction sites like the olefinic bond, double bonds, the phenolic group, carboxylic acid group. So you can check in this table the functional group contains in the residual lignin, basically free phenolic hydroxyl group, then aliphatic hydroxyls, aliphatic carbonyls, aliphatic carboxyls, aliphatic reduced units. Okay, these groups are there in the residual lignin. Now, as we have learned previously that in case of mechanical pulp bleaching, the chemical alters the lignin rather than separating the lignin from the pulp. That is, the chromophore or the color imparting element is there in the mechanical pulp even after bleaching. It actually altered by the bleaching chemicals. Chromophores are most often conjugated double bond system rising in the lignin of the pulp. Okay, Other chromophores or color imparting elements other than lignin are present in the pulp. Mechanical pulp may be sap stain induced by microorganisms, dirt, metal ions such as ferric that are complex with lignin, and water impurities may also impart certain color. So actually bleaching mechanical pulps is done to mask the lignin that is present instead of removing. So it is called as brightening. We have learned this. Now this brightening is accomplished by reducing agents such as dithionite or oxidants such as hydrogen peroxide, often in a single stage, but it can be into a two-stage process also. Okay, brightness improvement realized 6 to 12% typically. Okay, maximum brightness you can achieve 60 to 70% in single stage and 75% in case of two-stage process. Okay, pulp brightness is not only depend on the process by which you are actually doing the bleaching, it also depends on the wood species too, which kind of wood you are working with. Okay, and the mechanical pulping, for mechanical bleached pulp, the color reversion is there. The color reversion with time due to external stimuli is there. Since lignin is present, lignin is altered rather than removed. So and another thing that you will be learning in dithionite also, that the oxidative stage, if this two-stage process, oxidative stage is used before the reductive stage, or else the oxidant will undo what the reductive compound accomplished actually. So the this you need to remember. Okay, mechanical pulp bleaching by dithionite. Okay, this is also called hydrosulfite bleaching. Okay, hydrosulfite, the common name in the industry, but dithionite is the preferred name. Okay. Previously, zinc dithionite was used because it was very stable. It is very stable actually. But as zinc is toxic to fish, so sodium form of dithionite. Okay, instead of zinc, sodium form is used. Okay, and bleaching is carried out at the presence of chelating agent such as ETDA, that is ethylene diamine tetraacetic acid, or sodium tripolyphosphate, to prevent the metal ions such as iron from coloring the pulp. Okay, the brightness is gained by 5 to 8%. Now dithionite reacts with oxygen, so bleaching is carried out at 4% consistency. We have talked about consistency before, so that the consistency here is 4%. Consistency above 4% leads to the entrant air that consumes dithionite, and the explanation you can check at the bottom. Okay. Now dithionite ion reduces the lignin, and is itself oxidized to a sulfite ion actually. Okay, and if you are doing the dithionite stage in two stage, this is basically a single stage process, and if you are doing it in two stages, okay, the dithionite must be the second stage. Okay, or hydrogen peroxide will reoxidize basically. Okay, so the reaction of dithionite is shown below. Peroxide bleaching. So mechanical parts. Okay. Metal ions such as Fe3 plus, Mn2 plus, and Cu2 plus catalytically decomposes the hydrogen peroxide. So the peroxide bleaching is carried out in the presence of chelating agents. like your EDTA, like ethylene diamine tetraacetic acid, or sodium silicate. Okay, these EDTA have the added gain of preventing pulp decoloration, added advantage of preventing the pulp decoloration by binding with the ferric ion. Okay. Okay, definitely that would otherwise form a colored complex with the phenolic lignin structure. Okay. Now the sodium silicate, like the interaction, with the Fe3 plus CO2 plus with the sodium silicate is not that clear. It may precipitate the ion, but it generally acts as a buffering agent. Buffering reaction is actually required to keep the pH level high of the reaction. Now these are the bleaching conditions. Okay, with peroxide, 0.5 to 3% of peroxide and 0.05% magnesium ion is used. Okay, temperature is 40 to 60 degrees centigrade. pH is 10.5 to 11, and consistency of the pulp is 10 to 20%. Time required is 1 to 3 hours, and the brightness gain is 6 to 20%. Okay. Now hydrogen peroxide with the sodium hydroxide and sodium peroxide is used to produce this high pH. Okay, and this is necessary to produce the active per-hydroxyl ion. Okay. Some carbohydrate degradation occurs and like is responsible for about half of the peroxide consumed. Okay, the reaction of formation of per-hydroxyl ion, you can see at the top, but it produces at the pH level of 11.65. Okay, fine. Now the in mechanical pulping, as we have already learned that the lignin is not removed, rather than it is altered actually by chemical reaction. Now this altering the chromophoric group takes place, like chromophoric group such as orthoquinones takes place with the reaction of the peroxide. Okay, the pulp is sometimes subsequently treated with SO2 to neutralize the OH minus ions and reduce any residual peroxide. This is the graphical representation of the brightness level achieved by dithionite and peroxide when you're bleaching the mechanical pulp. Now, chemical pulp bleaching process. Basically, the chemical pulps are dark, very dark to begin with. Okay, as the lignin for the lignin content. Okay. Like from single to 7th stage bleaching can be used to increase the brightness of the chemical pulps. Okay. Definitely the steps or stages are due to the complex nature of the lignin. Lignin, as you have seen with different functional group in the previous slide, is a complex molecular different type of linkages. Okay. Now different chemicals in different stages, I have talked about 7 stages, will break various types of bonds, and it helps to increase the brightness. Okay, for example, say why these up to 7 stages may be necessary. Okay, say a large amount of brightness is required, so a small amount of ClO2 can be used at the latter stage, but that brightness you can achieve by a massive amount of Cl2, that is chlorine, in the stage 1. And if you use in the stage 1 large amount of Cl2, what will happen? Actually it will large amount of chlorine actually would cause much carbohydrate degradation in the very first stage. In chemical pulping, the brightness you can achieve up to 70 to 92% according to the stages you selected. You have selected now. The color reversion, unlike mechanical pulp, okay, there is a very less chance of color reversion, but at high temperature it may reduce some color reversion. During the lignin removal stages by different chemicals, the strength of the individual fibers is lessened actually. However, the strength fiber to fiber bonding increases after bleaching. Okay. Now, the most selective bleaching agents like chlorine dioxide, hypochlorite, hydrogen peroxide are expensive ones. So, the inexpensive ones like oxygen and chlorine are used at early stages of bleaching to remove most of the lignin, though these are not particularly selective for lignin removal. And now this table you can see the sequences. Basically you have as we have told about the 7 stages can be possible, like C stage, E stage, H stage, will be D stage, P stage, O stage. The explanations you will be learning in the next slides. Here you can see the pulp consistency, pH, temperature and the time requirement. Okay, and the brightness can be achieved for the processes. Okay, uh, so going to the next slide. So, in general, if you want to classify chemical pulping, bleaching of chemical pulps, it can be from single stage to multi-stage, and that multi-stage can be up to 7 stage. Okay. Now, talking about the single stage bleaching, it is done by using the expensive bleaching, more selective expensive bleaching chemicals like calcium or sodium hypochlorite. Actually, this is the oldest process, and especially produced by sulfite or soda process that can brighten up the pulp up to 80%. Okay, but serious loss of strength occurs as you are bleaching it by using in a single stage hypochlorite ion in a hypochlorite chemical in a single stage. Okay, so single stage is not so good actually for sulfate or high pulse unless you require a low brightness. Now results are like a minimum of purification, maximum chemical cost per unit of brightness obtained, maximum strength loss per unit of brightness as you are using a single chemical to brighten that up, to brighten the pulp up. Okay. The possibilities of reversion of color is more. Okay, and the advantageous thing is it is requiring a minimum investment per unit of brightness. Now, for multi-stage bleaching, as we have learned already, it can be up to 7 stage. Okay, but for now we are taking an example of 5 stage bleaching process. Okay, though we will be talking about the 2 more steps too. Okay, in the subsequent slides. For say a typical 5 stage bleaching, will be having the stages like chlorination, then alkaline extraction, then hypochlorite bleaching, then a second alkaline extraction, and then finally with treating with chlorine dioxide. Okay, so this is a typical 5 stage multi-stage bleaching. Okay, with it the oxygen bleaching and the peroxide bleaching are there, so that becomes 7. Okay, so the abbreviations also we'll be learning in the next slide, like the what is C, what is H, what is E, what is O, what is P. Okay, so in multi-stage bleaching, basically there are 2 steps. First is removing the lignin and its byproducts, and second stage is bleaching after the color producing substances have been eliminated. Okay, so there are 2 stages, two steps basically, and by using different chemicals you are achieving these two steps. Okay. During the early stages, lignin is progressively removed, and afterwards afterwards you are bleaching the pulp to decolorize whatever remaining substances is there, and you want to brighten that up. You want to increase the brightness. So the first stage is chlorination stage or C stage. In direct chlorination, the chlorine added directly to the pulp, either as chlorine gas or as chlorine water. Okay, chlorine is not that very soluble in water, but in presence of pulp, actually chlorine is absorbed readily. The chlorine should be added rapidly in order to lower the pH of the reaction mixture as quickly as possible. Now, when the chlorine gas is dissolved in water, we can see from the equation the equilibrium condition. Okay. Actually, it produces the hypochloric acid and hydrogen ion and chlorine ion. So, concentration of chlorine decreases and concentration of hypochloric acid and pH value increases. After that, hypochloric acid decomposes into hydrogen ion and hypochlorite ion, OCl minus. So, concentration of hypochlorite ion increases and also pH value increases, and the concentration of hypochloric acid decreases. In acidic medium, cellulose degradation takes place during the bleaching. So, alkali is added to reduce degradation. In the next step, actually, that is alkaline extraction, alkali solution is added actually. Okay, now the three chlorine species, that is Cl2, HOCl and OCl minus, exerts varying effect on the carbohydrates and lignin of the pulp. So, cellulose is known to become rapidly degraded if the chlorine treatment is carried out at pH level between 4 to 7. Whereas outside this pH range, the degradation is lessened. This indicates that hypochlorous acid degrades the cellulose most. Okay, now the reaction of chlorine with lignin can be by different chemical reaction like addition, substitution and oxidation, and that we'll be learning in the next slide. Okay, now the reaction of chlorine with lignin. There are three principal reactions occur in the chlorination of pulp. Okay. First is addition, substitution and oxidation. In addition, you can see RCH double bond CHR1 plus Cl2, which has been added, and the double bond becomes single bond, that is RCHCl single bond CHClR1. Okay. In substitution, it will be divided, RH plus Cl2 is equal to RCl plus HCl, and in oxidation, RH plus Cl2 plus H2O is equal to ROH plus 2HCl. Okay. Now, addition involves the reaction of chlorine with lignin at the unsaturated double bond or triple bonds. Okay. Thereby forming no byproduct. Okay. In substitution, you can see substitution involves the replacement of hydrogen atoms in the lignin molecule with chlorine, thereby forming one molecule of hydrochloric acid, okay, as a byproduct for each molecule of chlorine. Okay, now in oxidation involves the reaction with nascent oxygen with lignin, forming two molecules of hydrochloric acid per molecule of chlorine consumed. Okay. Now, ordinarily, from 50 to 75% of the chlorine applied in the chlorination of the pulp appears as hydrochloric acid, and the rest being combined with the solubilized material or reacted with the residual lignin in the pulp to form chlorolignin. Okay. Now the large amount of hydrochloric acid formed. See the hydrochloric acid form in case of substitution as well as oxidation. So the large amount of hydrochloric acid formed indicates that substitution and oxidation are the predominant reactions. Okay. The chlorine combined with the chlorolignin tends to split off when the chlorolignin are dissolved in alkali. Now, reaction of chlorine with carbohydrates. Okay. In addition to reacting with lignin, chlorine is also capable of reacting with cellulose under the condition prevailing during chlorination. Okay. The conditions you already knowing now. Okay. In such circumstances, chlorine is non-specific and react with cellulose at various positions on the monomer unit, with the result that carboxyl content are increased. Okay, their transformations are particularly pronounced at pH 2. Okay, now the alkaline extraction or E stage. Okay, after washing of the chlorinated lignin or chlorinated pulp, it is extracted with alkali to remove the remaining chlorinated lignin and water insoluble organic acids. Okay, by removing these substances with the alkali, less hypochlorite is required in the subsequent hypochlorite stage. Okay. And pulp, definitely pulp of better color results. Now, this normally NaOH is used for the alkaline extraction. NaOH is reacted with the lignin, chlorinated chlorolignin or chlorinated lignin, and produces lignin OH and NaCl, and thus it is separated from the pulp. The lignin in the this E stage effluent gives a dark color that is ultimately responsible for the dark color of the final meal effluent. Okay, recently oxygen gas is being incorporated for better results, which the term comes E0 actually. The hypochlorite stage or 8th stage. Okay, the function of this hypochlorite and the multistage bleaching is to remove the colored residue remain in the pulp after chlorination and alkali extraction by oxidation. Okay. Now the chlorinated and alkali extracted pulp still has a dark color because it contains appreciable amount of residual chlorinated lignin and other colored substances. Okay. So these substances are readily oxidized by the hypochlorite or by the nascent oxygen of the hypochlorite. Okay. The degree of previous chlorination and alkali extraction govern the amount of hypochlorite required in the final stage. Okay. Like reagents like the sodium hypochlorite or calcium hypochlorite are normally used. Okay. And initially the calcium hypochlorite was used for centuries actually, but now due to less scaling, sodium hypochlorite is also used, and calcium hypochlorite previously used due to less cost also. Okay, dissolving pulp are often bleached. The dissolved pulps are often bleached with sodium hypochlorite to minimize the calcium content of the pulp too, actually. Okay, so calcium hypochlorite is produced by dissolving Cl2 in the aqueous slurry of the calcium hydroxide, and the sodium hypochlorite is produced by reacting Cl2 with NaOH actually. Okay. Now the second alkaline extraction is for segregating the chlorinated lignin by using NaOH. Okay, now chlorine dioxide stage or D stage. Definitely this stage involves bleaching with chlorine dioxide. Okay. Chlorine dioxide is expensive, but it is highly selective for resin. Actually, it has a unique property in oxidizing the lignin without attacking the cellulose. So the use of chlorine dioxide as bleaching agent has increased over the past several years. Okay. Now, definitely, as it is expensive one, so this is normally used at the latter bleaching stages. Why? Because lignin presence is less at the latter stage actually. At the latter stage means after these 4 steps, or after like the initial steps, this chlorine dioxide is used for bleaching. Now this stage is very useful for reducing the sheaf content also. Okay, there are other advantages of this chlorine dioxide addition too. First, say it gives a very bright pulp without or with a minimum cellulose degradation. Next, bleaching with chlorine dioxide, the advantage of bleaching with chlorine dioxide is that dirt and specks are decolorizes more easily than hypochlorite bleaching. It shows less tendency to revert color. Reversion is less actually than hypochlorite bleaching. Okay. Chlorine dioxide may be used instead of chlorine for the first stage of bleaching to lower the resin content. Okay. But as its cost is higher, so it will cost more, because at initial stages more amount of chlorine dioxide has to be used. But chlorine dioxide, if you use, okay, in the chlorination stage, the pulp results actually the results are like improved viscosity of the pulp actually. So it is advantageous one. Now at the final stage, it is very essential that bleached and the washed stock or the pulp should contain no available chlorine. So anti-chlor agent is used to reduce the chlorine. Okay, normally Na2S2O3 is added in diluted solution as anti-chlor, but they have a destructive influence on the machine. So safer anti-chlor agent are Na2SO3, CaSO3. Okay. Now talking about the P stage or the peroxide stage. Okay. Okay. Now bleaching with hydrogen peroxide, as we have already learned, is not common for chemical pulp. It is common for mechanical pulp actually. But the trend is changing as mills are looking for chlorine-free system for chemical pulps too. Okay. When it appears to use that peroxide for chemical pulp, actually it appears at the last stage of the sequence, like it can be CEHP or CEH. DP. Okay, the sequence name abbreviation by now you will be familiar with. Okay, now the consistency is 10% and it is operated at 60 to 70 degrees centigrade, pH at 8 to 10 and for 2 to 4 hours. But it is fairly similar with the mechanical pulp except for the higher temperature, as you can see. Okay, it is an expensive bleaching agent, but maybe used more frequently as the use of elemental chlorine is decreases actually. Peroxide oxidizes basically the carbonyl group of carbohydrates that produces by oxidants such as hypochlorite in the hypochlorite state. Two carboxylic acid groups actually. Now the O stage or oxygen bleaching. Okay. Uh, Actually, oxygen bleaching is used prior to the chlorination. Okay, bleaching with oxygen is a delignification of pulp using oxygen under pressure of 80 to 100 psi and in the presence of NaOH. Okay. This is odorless, relatively pollution-free process, and it can be used at higher consistency, that is 20 to 30%, and medium consistency, that is 10 to 15%. Delignification is done at 90 to 130 degrees centigrade and for 20 to 60 minutes. But this is a process which is done prior to the chlorination, that is C stage. Now the key to use this O2 delignification is actually found after discovery of small amount of magnesium ion, okay, that must be present actually to protect the carbohydrate from extensive degradation actually. Okay, this is the most inexpensive bleaching chemical to use, and though this is least specific for lignin removal. Okay, here a considerable decrease in cellulose viscosity occurs in this process. Here you can see the relative reactivity of lignin compound with oxygen, like the phenolic hydroxyl functional group, like with methoxyl. Okay, so here you can see a schematic diagram of a CHDP sequence used to bleach a pulp up to 90 to 92% brightness. Okay, here you can see the stages are CEHDP, that is chlorination, caustic extraction, hypochlorite stage, then your chlorine dioxide stage, peroxide stage. Here you can check the temperature, time, consistency, pH as well as brightness. Now here in this slide you can check the example of reaction of bleaching agents with lignin. Okay, you can check it out. Now bleachability. Okay, bleachability is basically defined as the amount of bleach required in the bleaching operation. Now this serves as a guide and control for the cooking operation too. Okay, now if pulp bleachability is low, that means pulp is highly purified. Listen to it very carefully. If the bleachability is low, that means the pulp is already highly purified and will not beat as readily as the same type of pulp containing more hemicellulose matter. Okay, as it is highly purified already. Okay, but if the bleachability is extremely high too, that means okay, it is hard cooked, its resinous content is more, and as a rule will not develop strength on beating. Okay, now you do not know what is beating. Beating is a process which you will learn in the next operation, that is stock preparation. Okay. After learning that stock preparation, you will be understanding this term in a much better manner. Okay, so for now, beating is beating, as the term suggests, to beat actually. Okay, okay, for uniformity of the pulp actually. This is a mechanical means by which you uniform the pulp. Okay, and intermediate bleachability is required, actually desirable for easy beating and to produce strength in the pulp. Okay, intermediate bleachability, that means it is not hard cooked, or it is not that having a low bleachability. Okay, so bleachability, intermediate bleachability is what is needed. Now, how you can identify the bleachability? Okay, there are certain identification processes. Okay, number one is by Kappa number, number two by permanganate or K number, number three by rho number, number four by chlorine number. Okay, now the first test is the Kappa number. Kappa test is an indirect method for determining lignin. Okay, the Kappa number is the number of milliliters of 0.1 KMnO4 consumed by 1 gram of pulp in 0.5 N sulfuric acid after a 10-minute reaction time at 25 degrees centigrade under conditions such that 1/2 of the permanganate remains unreacted. Now this 50% residual permanganate is titrated to determine the exact consumption. Experimentally, 30 to 70% excess is common, with factors to convert these to 50%. Okay. Now the Kappa number test can be used on bleached, unbleached as well as high yield chemical pulp by use of single scale. Okay. Bleached pulp always giving a low number and unbleached pulp gives high number. That is higher lignin content. Okay. Now a variety of lignin content are accommodated by varying the amount of pulp used in this test, but keeping the amount of KMnO4 constant. Just listen to it very carefully. A variety of lignin content, actually, like, because you are getting the lignin content of unbleached as well as bleached pulp. Okay, so a variety of lignin content are accommodated under this test. Okay, by varying the amount of pulp, okay, used in the test, but keeping the amount of KMnO4 constant. Okay, now permanganate number or K number. Actually, this number is really for different tests. Okay, a constant amount of pulp is used with either 25 ml or for bleached pulp, definitely 40 ml, 75 ml or 100 ml of permanganate. So, constant amount of pulp is used with 25, 40, 75 or 100 ml of permanganate. Okay. Now, results of the 100 ml of K number test are not easily compared to the result of 75 ml or any other K number. So, there is no continuum or results for all type of pulp as with the Kappa number. Actually, these are 4 different tests. Okay, now the Guillory gives the relation between the Kappa number and the K number. That is, log Kappa number is equal to 0.837 plus 0.0323 into 40 ml of K number. Actually, the 40 ml K number you get when you are using 40 ml of permanganate. Actually, therefore 40 ml K number of 10. Actually, the results is for 40 ml K number is 10, corresponds to the Kappa number of 14.5. Okay. Now the rho number. Rho number is basically the number of gram of gaseous chlorine consumed by 100 gram of dry or moisture free pulp at 25 degrees centigrade in 15 minutes. Okay. Now Alander and et al. Gives the equation for this number related, how it is related to the Kappa number. Okay, for hardwood pulse is rho number is equal to 0.158 into Kappa number minus 0.2, that is for craft pulp, and rho number is equal to 0.199 into Kappa number plus 0.1 sulfide basically. Now chlorine number. Chlorine number is basically similar to the rho number, except that the chlorine dioxide is generated in situ, that is on site, by the acidification of the sodium hypochlorite. Okay, now this chlorine number is equal to 0.90 into rho number. Okay. Now class on lignin or acid insoluble lignin. Okay, class on lignin is a residue obtained after total acid hydrolysis of the carbohydrate portion of the wood. Okay, this is a gravimetric method for determining the lignin. Okay, directly in the woody material. This is basically used at the laboratory. Okay, wood meal or treated with 72% of sulfuric acid at 20 degrees centigrade for 2 hours, followed by the dilution of 3% sulfuric acid and refluxing of 4 hours. Well, now you must be knowing why the bleaching is done. Okay, for several reasons. First, the printing contrast improves as the whiteness of the paper increases. Whiter paper are aesthetically desirable. Colored paper become more brilliant when made from whiter pulps. Bleaching contributes to the chemical stability, purity and permanence of chemical pulps. And bleaching is necessary for sanitary reasons too. For example, food packaging papers, okay, and for others. So thank you. That's all for today.